the installation of large-scale battery energy storage systems is really at an inflection point. Big batteries have honestly demonstrated their worth and their value to electricity networks and to the asset owners over the recent years. And the actual financial case for large-scale batteries is becoming more compelling each year as renewable penetration continues to grow. But the safe operation of these large-scale batteries and ensuring that the assets don't degrade prematurely isn't entirely straightforward. And for such a young technology, there's still a lot to learn. Hello and welcome to this PV Magazine webinar. My name's Jonathan Gifford. I'm the editor-in-chief of PV Magazine Global. The title for our webinar today is Analyze BESS, Online Diagnostics for Safety Performance and Extended Lifetimes. The webinar is being delivered in partnership with Accure Battery Intelligence. And today we have a presentation from Kai-Philipp Kairies, the CEO of Accure, just a little bit later on. The presentation will set out the principles behind battery data management and what it can reveal with some real-world examples of how things can also go wrong if battery systems are left to their own devices. We're also going to take a look at some recent high-profile large-scale battery incidents, including fires. And they're the kind of things that capture headlines and also should be avoided if investors are going to continue to put their hard-earned money behind big batteries. Now, before we begin our presentations today, you might be joining a PV Magazine webinar for the first time. So welcome if that's the case. And here's some information about how you can get involved. Please feel free to send through your questions. Absolutely do not hesitate to send through your questions at any time. I'll be kind of feeding them through the discussion with both of our presenters today. And we'll also have a quickfire Q&A round right at the end. I really want to get to as many of your questions as we can, so don't hold back. And if you do experience any technical problems, please don't hesitate to get in touch. Let us know. You can do so right here on the Big Marker platform. So send through your technical problems if you experience any, and our tech team is standing by to help. One quick tip, if anything does go wrong, just refresh your browser. It often solves a lot of problems in one fell swoop. One question we always get is, will there be a recording of this webinar? And yes, indeed, there will be. And we will also provide you with copies of the presentation. So keep an eye on your inbox for links to the recording and also links where you can access the presentations themselves. You can also share links to the recordings to friends and family and colleagues who weren't able to join today. So without further ado, we've got a lot to get through and we really want to get to your questions. So let's move straight to our presentations now. Our first presentation comes courtesy of Blake Matic, who is an editor with PV Magazine Global, was formerly an editor with PV Magazine Australia, and Australia has really been one of the vanguard marketplaces for large-scale battery energy storage systems. And unfortunately, it's also been a place where some fires have occurred. For the last 6 months or so, Blake, you've been looking into these fires and also some other issues that have occurred with large-scale battery systems. So can you provide us with a bit of an update, a bit of an insight into what has gone wrong on some of these occasions and the latest information about what we can learn from them?
Yeah, sure. Thank you, Jonathan. I thought this would be a great time to chip in with a couple of case studies about recent high-profile events in the Australian utility scale market, because it is such a frontier and therefore it is experiencing growing pains which other markets might not be experiencing, but also therefore gaining the learning curves that we need to make sure this transition happens as safely and as smoothly as possible. I've got two case studies within the parameters of safety and performance I thought I'd dig into. The first being a fire which ignited at the Victorian Big Battery during commissioning last year, and the second being an ongoing federal court case involving the Hornsdale Power Reserve, otherwise known as the Tesla Big Battery in South Australia. So kicking off with the fire which occurred at the Victorian Big Battery. Here you can see a timeline of the event. And don't strain your eyes. And as Jonathan said at the top, these slides will be available. I'm about to go through this incident, so no zooming in necessary. We'll just jump ahead. So you can see that the fire started.
Ooh, has Blake frozen for everyone, or is that just me? Let's just have a look. Blake is frozen for me at this stage. So let's look at just maybe if there's a case of that requiring some refreshment on Blake's side of the webinar. Beatrice, are you able to scroll through the slides also? The fire occurred, here we go. So as Blake mentioned, the fire occurred actually while the battery was still being commissioned. This is the VBB, and it was a really landmark battery installation in Victoria. Victoria is an interesting example where some very large coal generators are coming off the grid and big batteries are being added. Blake, you're back. You froze for a moment. Can you take over the presentation? I just tried to step in, but of course, you know this case far better than I do.
Sorry, Jonathan, I had no idea. I thought you were interrupting me. So
no problem.
Oh, a question's coming in already. Fantastic. I've sparked interest. Do I seem perfectly fine now?
Yeah. Well, as good as you'll ever be, mate.
Well, yes, I can only apologize. As you can see from this image, we can see the white smoke coming off, and unlike the Vatican, it's not a good sign. If it was black smoke, you could, believe perhaps it's just the plastics burning. White smoke means that there is chemicals involved, and therefore it could be quite dangerous for the firefighters if they open the door. So these, which we'll get into that a bit later. But as you can push, if we just move the slide again, we push on. The fire went on for 4 days, or it leaked into a 4th day rather, which was more precautionary than anything else. But it did require quite consistent dousing for 36 hours at least to make sure that the fire didn't spread to any further adjacent megapacks. And then by 6:36 p.m. on the Saturday, 31st of July, the advice warning was lowered to the toxic smoke warning was lowered to an advice warning. And then if we pop ahead again, you can see that there's quite a bit of space where this battery could be spread out a bit further, which was one of the learning curves that this fire demonstrated, is that Australia's got a lot of resources when it comes to the renewable energy transition, and land is one of the main ones. Considering that firefighters would prefer to have more space to maneuver or to have fire hydrants at the ready in these utility scale installations, perhaps a good idea would be to make sure there's a bit more room to move on these large scale systems. Now, there was an investigation led by the Energy Safe Victoria and cooperated by Neon and Tesla. And a initial publishing of findings was submitted or made public in the end of September 2021, and then a larger independent analysis in November. What the findings showed was that the most likely root cause of the incident was a leak within the megapack cooling system, which caused a short circuit, which led to a fire and a thermal runaway event, which obviously led to the adjacent fire in the next megapack. As you can see in this photo here, the megapacks are about double the size of a ute. So you want to make sure you get it under control pretty clearly. I'm just being told to keep my camera off. I hope I'm still audible. And I will shift across. As you can see, the report showed that the ignition of the fire from the coolant leak should have been made aware to the system operators had the monitoring services been switched on. But as they were in commissioning, they were switched to an offline mode as they moved from megapack to megapack. So that's another learning curve we encountered with this fire, is that you should make sure that there is no offline monitors at any point, because a thermal runaway event could ignite, and if you don't catch it early, then you could be in trouble. But I guess it is good to know that if they should have been caught early, then the incident was quite avoidable. Now, moving on to the second case, which is a case which involved the Hornsdale Power Reserve, otherwise known as the Tesla Big Battery in South Australia. And it involves the Australian Energy Regulator and the Australian Energy Market Operator, who have taken the Hornsdale Power Reserve to the federal court, alleging that the big battery didn't provide frequency control ancillary services, FCAS, between July and November 2019, although the Power Reserve had promised it would provide those and had actually been paid for that assurance. So during that time, the Kogan Creek Power Station in Queensland tripped and led to an outage event, which somewhat compromised the entire national energy market, the grid in the eastern and southern part of Australia. And AEMO wasn't able to call upon the Power Reserve at this promised for these promised for services. If we jump ahead, this is Kogan Creek. You see here, it is Australia's most recent coal-fired power station. And also, according to the Australian Institute's Gas and Coal Watch, the single most unreliable generating unit in the NEM, having tripped 13 times in the 2 years examined. So clearly, the promises proffered by utility scale batteries are taken very seriously by the energy market operator, by the AER and AEMO, and they were not happy to not be able to rely on the big battery when this tripping event did occur. AER claims that the Power Reserve's failure to provide promised capability created a risk to the power system security and stability, with Chair Claire Savage saying that contingency FCAS providers receive payment from AEMO to be on standby to provide the services they offer. We expect providers to be in a position and remain in a position to respond when called upon by AEMO, adding that it is vital to generators that they do what they say they're going to do. AEI is seeking pecuniary penalties and declarations and costs. Now, Neon Australia did not directly respond to the allegations, but Managing Director Louis de Sambucy made a statement saying that HPR had repeatedly, that's the Hornsdale Power Reserve, had repeatedly delivered on high expectations since it opened for business in 2017, adding, whilst we were disappointed by the AER's decision, we will continue to maintain our collaborative relationship with them. And that is no surprise considering how lucrative that relationship has been, because those FCAS services have already enabled the Hornsdale Power Reserve to more or less pay for itself. In this graph, you'll see the FCAS services demand shoot up in that massive column in Q1 2020, which is when the interconnector, the Hayward interconnector between South Australia and Victoria, was compromised by weather events and was down for 18 days. Meaning that the Hornsdale Power Reserve really came into its own. And of course, as many people know, that massive windfall also encouraged Neon to complete a 50% expansion in September of that year, 2020. Which you can see that expansion in progress there. And the enormous windfall they also got of AU $258 million in that quarter. Now, the AER said there is no update on this litigical matter at the moment, but the hearing is set for February 24th under Justice Basanko in the federal courts, so we can expect sometime in mid-February to have more of an update. But it is interesting to know or to look at these two cases as a performance and a safety case of what can happen, as we're on these foothills of the utility scale market, of what can happen with a safety incident and what can happen when perhaps a new to the market utility scale battery isn't quite ready to respond to certain incidents, or perhaps made promises that it wasn't able to fulfill, any number of reasons. I don't have the specifics yet, but these are great learning curves, I think, for the future of the market. Jonathan.
Thank you very much for that, Blake. So just to kind of sum that up, we had two case studies here, the VBB, which is the Victorian Big Battery. So that was under commissioning when the fire took place. We have a couple of questions coming through, and in the subsequent investigations as to why the fire kind of got out of control. So it started in one pack and kind of spread to another. And that was deemed because monitoring wasn't in place to pick up that initial fire. Is that right?
Yes, that is correct. So they were commissioning, and so that process goes from megapack to megapack as they do testing of each one in a series. And apparently, as the situation or as the standards were going on, they would turn on one megapack, do all the test, and then more or less turn it off, or as far as they were considering, as far as they were aware, turn it off and move to the next one.
Okay, so
there's obviously still, a leak can start when you've turned the battery on. All sorts of electronics and chemicals are then flowing, and then the monitoring was turned off altogether for each pack as you move across as well. So an alarm would have normally gone off if this incident happened during normal running. But in this case, obviously they need to, and Neon has since confirmed that they've adjusted all their commissioning standards to make sure that monitoring devices are on 24/7.
Yeah, okay, so they'll be monitoring it throughout the whole commissioning process. And we have a question from an attendee. What was the trigger for the fire? Do we know what actually was the cause?
A coolant leak is the most likely culprit. And that could be any number of reasons why the coolant leaked. I'm not exactly sure. It's quite a complex business, obviously a megapack, but I wouldn't say either that it did get out of control. It did spread obviously to one adjacent megapack, but it did, didn't get any farther than that. And
okay. All right, we'll just keep pushing forward with the questions. And the battery chemistry, so it is a Tesla megapack, so that's a lithium-ion battery chemistry.
That is correct. Yeah.
Yeah. And what about the local firefighters? I know you're in touch with that. We have a question saying, are there any special procedures for the local firefighters to respond to the fire? And what did you learn from your communication with them?
I learned that they're very experienced with fighting all sorts of battery-related fires, and that each one has its own particular, obviously, chemistry, and then therefore way to treat it. People think, you don't douse lithium-ion battery fires with water. You've got to put powder. That can actually cause more problems. There's other things, other suggestions. For instance, when a smaller lithium-ion battery, such as in a Tesla car, if that is compromised, then you can pour concrete on it. But actually, that's a band-aid solution. There's still a compromised battery which is in that cement, and then it's standing in the middle of the road or whatever. That doesn't actually douse the fire. Really, there is just the use of good old-fashioned water when it comes to lithium-ion fires, making sure it doesn't spread, and letting that, however much energy is stored, burn itself out in a controlled way, which, as you can tell from firefighters and wanting to make sure that they've got the right facilities and the right room to move and maneuver. And as you can tell from the kind of leaking into a fourth day VBB incident, that's a lot of hours to pull, and they want to make sure that the whole situation's under control. It doesn't keep getting worse and worse and drawing on resources.
We actually have a question about the spacing of the individual containers as to how close or how far apart they were placed from each other. What did the fire services say? It was the Victoria Country Fire Authority and the Fire Rescue Victoria. What did they say about in terms of access to these battery fires or battery sites if there is a fire that takes place?
Again, it's quite case dependent, but from the fire service representatives that I talked to, they're very keen to have permanent sources of water available to them, so they don't have to bring their own and keep replenishing it. So they would like to have space for their own hydrants. They would like to have space to be able to make sure they can maneuver, get to each entry point of the megapack. In case one door is compromised, they can go to a different side. So a bit more space between the packs would definitely be welcome, and the ability to actually get or have their own water sources within the kind of maze of the packs would also be a welcome addition.
Okay, well, we've got lots more questions coming through, Blake, so stick around and for the Q&A a bit later on, but we'll keep moving forward with our next presentation today. And thank you very much for all of your questions. I will be getting to as many of them as possible. And we've got another battery expert joining us, so hopefully he might be able to answer some of the questions as well. Kai-Philipp Kairies is our next presenter, the CEO of Accure Battery Intelligence. He's a scientist and entrepreneur focusing on innovative storage solutions. He worked as a battery researcher and consultant in Germany, Singapore, and California, and has been the CEO of Accure since 2020. Kai-Philipp, welcome today, and thanks for joining us.
Hi, great to be here. Thank you. So, yeah, that's just for the slide deck later on. I think these were two extremely interesting case studies about, what can happen with big batteries in terms of safety, in terms of performance. There haven't been too many big batteries around for a long time, so aging should be not an issue for most of the systems that are online today, but certainly also will be in the coming future. If we talk about performance, safety, quality of batteries in general, there's a few challenges that are around. Batteries are still somewhat mysterious to many people using them, to system integrators, to operators. We have lots and lots of different battery types, cell chemistries, form factors, system designs, and supplies around, and new companies popping up here and there every month. And then we have development cycles that are extremely fast. So every 18 months, every 24 months, cell suppliers will give you a new generation of cells that might have nothing, or at least not much, to do with the old ones. And that's the only one you can buy then. So people they have to work with what they can buy on the market. If we talk about quality, safety, lifetime of batteries, there's a few different angles that we can have on the topic. We need a very high production quality. We need a great system design. We need to make sure the batteries are operated in a good way. And there's the aspect of battery data. And only if all those four pillars come together, we can make sure to have an excellent system. And today, as the title of this presentation indicates, I want to talk about the aspect of battery data. And one thing to mention, I think most people might be aware of that, all lithium-ion batteries are basically IoT devices, Internet of Things devices. So they all have, some sensors, they all have some logic, they're gathering data during operation. The data we're talking about is basically voltage, current, and temperature, plus some other measurements and some other estimations. And this data is generated continuously on a second or minute level and can be sent to a central server. And this is the scenario that we're taking. And we want to find out, or I want to discuss with you a little bit, how this data can be used to make batteries better. And there's a lot of things happening on the way from data coming in from a battery site to, being able to make something out of it. And this is a flow chart. I don't want to go into too many details. There's algorithms involved, machine learning, there's data cleansing. We need comparable data from a database that we can match certain systems with to gain insights. But for this presentation today, I'd like to focus on two things, and that's the actual results you can take from this, and a few things about which data do we need to get there eventually. And to make it a little bit more interesting, I want to start with the end. So I want to start with the value that we see such data analytics can provide. And if that's interesting to you, you can stick around to the last part of the presentation, where we're going to look into how can we enable such monitoring in a system. Okay, and so all the results that I'm going to show you, it's all real life results based on diagnostics that we did at Accure. We're a data management platform for batteries. We have about 1 gigawatt hour of battery storage under management today, and we're growing quite fast. And so all the results you see, it's not a simulation, but this is real life data that we've seen with customer of ours. And it's all anonymized, obviously. So I want to focus on 3 topics today. That's performance, safety, and health. And for each of those, I'm going to show 1 or 2 examples. There's a lot more that we could discuss, but we only have an hour. So I'll try to keep it short and interesting. Anyone who has dealt with renewable energies, with solar and wind farms over the past 1 or 2 decades, knows that monitoring and management tools for those assets are market standard. So questions like, is my asset performing as it should be in terms of revenues or yield, in terms of OPEX, operations and maintenance costs? Will my asset be able to operate as planned tomorrow, next week, the month after? Is the asset running as my supplier promised? Do I maybe have some warranty claims? And also, especially if you're managing multiple sites, how do the different suppliers, how do the different companies benchmark against each other? And one number that I found from my earlier days of working also in solar was that with a good PV monitoring system, the yield, by optimizing, the yield and also the costs, can be improved by 11%, which is a big leverage on a large farm. So this is like the traditional world of asset management for PV and wind, but what about batteries? There we go. Batteries share many of the challenges that PV and wind systems have, and add a few on top. And these challenges, these additional challenges, include which battery type is suited for which application. What about the availability and the efficiency of the battery? The quality of state estimation, we're going to look into that in a second. The usable capacity at different temperatures, at different state of charges, at different power levels that were before. The power capability at different state of charges, at different temperatures. All these might be restrictions that some might not even be aware of that could conflict with the application that you're using. And actually, I have a feeling that one or more of these points might have happened at the Hornsdale site, which was not working as intended when providing frequency control reserve. And one example I'd like to give you that's very battery specific is the quality of state estimation. State estimation, for example, is the state of charge of a battery, because the state of charge of a battery cannot be measured. It's something that you have to calculate. And whenever you calculate or estimate, that would be more correct, something, there might be an error. And so we just compared the local estimation of one of the sites that we monitor and recalculated the state of charge in the cloud with our own algorithms. And you can see just pretty randomly picked 1 week of operation for a large-scale storage system. And the difference between the green and the black line is the error that we see on this system. And because it's hard to grasp what this means from this picture, I did some statistical analysis of it. So in the top chart, you can see the delta, the difference between the green line and the black line. And in the bottom chart, you can see a histogram of the same value. So how often did we have a difference of a certain size over this week? And you can see that the difference between the measured or the locally estimated state of charge and the real state of charge is in a range between up to 5 percentage points. And if we're generous and say, well, it's about 3% only because the 5% don't happen so often, this means on a 50 megawatt hour installation that 1.5 megawatt hours, so about a full container, is unutilized, because either you have to put in some safety buffer, because if you know the estimation isn't great, you don't want to run into trouble, or you're risking that someone might try to use the battery, but because of a wrong state estimation, there's nothing left to use. And then you have to pay a fine. And with 1 megawatt hour being in the range of 200 something to 300,000 euros, that's quite something that people should be thinking about, at least. Another point, of course, is efficiency. For example, if you're doing arbitrage, if you run a lot of energy through your battery, through your inverters, you want to make sure that as much of that energy as possible is being fed into the grid again later, because it's basically money that you lose. And I would say we saw quite some surprising results in the efficiency that we calculated, that our partners and customers were not so aware of. And so this is definitely something where you can also optimize quite substantially. The next thing, safety. Actually, just this week, there were 2 more fires in the last 6 or 7 days. There were 2 battery fires in Korea. I hadn't really had the time to read into it in detail, but it was large-scale installations in containerized solutions. I think one of the systems was an LG Chem battery. The other one, I don't know. So Blake already talked about it. All energy sources carry a certain risk of failure. Like, batteries are nothing special about it, and batteries are not more dangerous than other energy installations. But of course, as with all energy installations, we should take all the measures to make them as safe as possible. And one way to improve the safety of such installations, we believe, is data monitoring. We published a white paper on this topic. You can download it for free on our website. I'm going to take 2 examples from it now to present them to you and discuss quickly what the things are that you can do, how it works. So the first example that you can see here, for the trained eye, this is something that obviously should never happen. For everyone else, I'll try to give a brief explanation of what we can see here. We see the cell voltage of a battery over a time of 8 months. And the lithium-ion battery, this is an NMC type, I believe, usually has a window of operation that when it's fully charged, it should be somewhere around 4.15, maybe 4.2 volts, and it goes down to about 3 volts, 2.8, 2.9. And the 4.2 volt is really like a hard limit for most NMC technologies. The one that we see here was actually specified for 4.15. So that's the maximum voltage this cell should have according to the supplier. And now we look at month 1 and we see that the voltage, the full charge voltage, the upper end of the green curve, is in a range of 4.16 maybe, but yeah, seems about right. And then moving towards month 2 and 3, we see that the full charge voltage kind of more and more often reaches 4.2 volts, which is technically still okay, but actually more than specified already. So we have this yellow line indicating something's going on that we didn't expect, but it's not critical yet, I want to say. And by the way, we got this data. This is historical data that we got, so we would have ended the operation much sooner if we would monitor something like this live. And moving on to month 4, 5, 6, you can see that now almost every day the upper voltage limit is beyond what the cell is specified to. And towards month 7 and 8, you can even see the battery going to 4.3 volts, which is not a reason to start running away right now, but it shows that there's a systematic error with this cell and with this whole system. And if something like this goes unchecked, there might be other things that we should maybe worry about. So this is a very obvious case of why did this happen? And the value really of another level of monitoring in its very simplest form is having sanity checks on the operation and making sure that everything is in an expected range. Low-hanging fruit, pretty easy, but pretty effective as well. Of course, it's not as simple as just, comparing two values. You need to make sure that all the values are cleaned properly, that you have systematic and random errors on the measurement filtered out. You don't want to throw an alarm to the fire department every time your logger is rebooting. So there's actually quite some work that you need to do in order to be able to make a comparison like that. But from all of the analytics that we do, it's, I would say, probably the simplest. Moving on to something that's a little bit more technical and a little bit more for the battery nerds, maybe. You know that during the operation of a battery system, we have certain aging mechanisms. And these aging mechanisms on a empiric level are basically a loss of capacity and an increase in internal resistance. But on a more detailed level, we know that what triggers the loss of capacity and the increase in internal resistance is loss of active lithium. We have corrosion, we have loss of active materials and all these things. And with the analytics that we do, and I'm going to come to this on the next slide, we have some pretty cool research cooperations going on this topic. We are able to identify some of the root causes of the aging. And what you can see here in this slide is you can see one of those parameters, the loss of active lithium that we see in the cell, where we expect a certain loss every year, nothing crazy. But in this cell, we can see that it accelerated substantially after about month 7 or month 8. And this is worrying because where is this lithium going? And so from an electrochemical perspective, we can now see that this cell is not behaving as expected in a bad way. So if we lose lithium in a cell and we don't know where it's going, that could be plating. Probably there might be some other reasons for it, but plating would be something that's also safety critical. And here we could eventually, intervene and say this cell should not be operated anymore. The great thing about all these diagnostics that we do is they don't require additional hardware. So the system that you have is already able to run these, or to supply data to run these algorithms. I was talking about electrochemical identification of things. We're super happy to work together very closely with two of the world's leading research institutions on the topic, Professor Sauer from Aachen University, Professor Dubarry from Hawaii University, who are really pushing the envelope on these topics. And we as Accure basically try to bring this research into a scalable way to the application. The advantage of it, really, I think it's pretty straightforward. If nothing happens to a system, that's great. So having a safer system without spending more money on additional hardware, that's a cool thing. And what I really love is we were able to also work with one of the largest insurance companies of Germany to work on battery insurance products for large-scale batteries. And this is HDI from Germany, but they're operational around the world. And so if you're interested in that, together with them, we offer smart property damage, fire, operation interruption insurances. And I think it's really exciting because obviously if you know more about the risk, you can give a better insurance. Whereas if you don't have any eyes on the targets, it has to be more expensive compared to something that's based on data. Yeah, so last topic I'd like to talk about is battery health. And this is a diagram I had the pleasure and honor to write a guest article for PV Magazine a month ago, I believe, maybe 6 weeks. And what you can see here on the right-hand chart is a comparison of 4 different types of batteries in relatively similar applications. It's not exactly the same application, and it spans over a larger fleet of systems, but it's relatively close. Not very scientifically, but what I want to show you is that we do see a few things. And one of those things is we see a substantial difference in the aging. We also see that the spread of the parameters increases over time, which is another point that's really interesting. And that generally aging of batteries should be something to think about, because if you look at the lowest curves that we see here, that's a battery that after 6 years, basically most of the battery modules of this type were around or below 80% of their initial capacity. And so if you run a simulation of revenues and everything, and then you only have 80% of your asset after 6 years, that does something with your calculation, and also with your availability to provide a certain amount of capacity. This is a small bit about battery aging that I like a lot, maybe a bit nerdy. The chart is from one of my former colleagues, Baumhofer, who analyzed how the batteries change as they age, even if we look at exactly identical batteries under an exactly identical use profile. So what you would expect as a layman is if everything is identical, the result should be identical too, but it isn't. And you can see that on the right-hand side. Exactly same battery, exactly same usage, and the spread towards the end of lifetime is about 30%. And you can see that spread in capacity, in internal resistance, in the open circuit voltage curve. What does this mean for us in the real world? It means even if you have a pretty good battery supplier, some of the modules will age quicker than others, which means you might come into a situation where you have to replace some of the models. But mixing and matching a 6 or 7-year-old battery with a brand new one, you shouldn't do it in your remote control, and you shouldn't do it in your battery system. So we need solutions to deal with that. And I really believe that battery analytics that enable you to make smart decisions on which batteries to change and how to mix and match them, that's a great idea. And it's especially important if we talk about second life use cases, where you basically start with old batteries to begin with. And wrapping it up, if you're still interested, if you believe that data analytics for batteries are something that you should be reading up on, or that you want more information on, I'm not going to go into detail on the data gathering now, but instead I thought I could provide 2 resources for you to do your own research. I wrote an article about the whole chain from data generation through data cleansing, through the SCADA system into the cloud, and what we do with it. It's about 13 minutes or so, the article says. That was calculated automatically. It's on Medium. You can access it for free. And the other one is a battery checklist, a battery data guide, we call it. It's a 2-pager where we summarize the most important data that you could and maybe should require from any supplier of batteries to make sure that you have all the information you need to make informed decisions. That includes datasheet values, metadata, like capacity, rated voltage, and such things, but also operational data. And I think this is, no matter if you want to do it in-house or if you want to do it with a platform provider like us, it's great to make sure you get all the data, ideally before you sign the contract, because that's usually the part where your supplier is most open to such things. Yeah, that's the source of if you really want to dig deep down into the battery research from Thorsten. And with that, I'd like to thank you for your attention. We do have a small poll. Really excited for that, and also for your questions.
Okay, thank you very much, Kai-Philipp. Kai-Philipp is the CEO of Accure Battery Intelligence. Thanks for that presentation. Quickly, let's go through some polls. We've got lots of questions for you, Kai, so stick around. But we've got 3 questions for you, our attendees today. If you could quickly answer these polls, that would be of great assistance to us. How do you handle battery data? Poll number 1. Are you not gathering data? Are you gathering data but not using it? Are you gathering data and using it with limited success or with great success, gathering and using it well? Great to see your results coming in as this kind of settles down a little bit. We could do a running commentary. Kai, does this surprise you? Not gathering data is kind of leading the way at the moment, which is perhaps a little bit worrying, but with limited success kind of leading at the moment.
Yeah, I think, like, not trying to advertise Accure here, but no matter what you're doing, getting the data is a great idea. And so if our battery, checklist can help, just go for it, because asking for data after you've signed the deal becomes more and more difficult, because many suppliers don't want to put you into a position where you have all the information because you can use that against them. So, as early as possible, make sure that you have in your contract to get full access to all of the relevant data.
Yeah, so you can know at least a little bit what's going on inside those boxes, the black box, or rather white boxes as they are. Poll number 2, let's move forward. Who should run the data platform? Who should run the data platform? Is it the battery supplier, an independent third party? Should you have to do it yourself, or you're undecided? What do you think? Who should actually be running this battery data platform? Is this poll open? We're not seeing. Oh, there we go. We're getting some results coming through now. And then third party is out in front. I think that would align quite well with your expectations, or at least.
I mean, that's the hypothesis we've built this company on.
Right.
So it's kind of reassuring. But I mean, we do see, large players in the field that, have the capability of building something in-house like that. But, we've grown to 40 people. We're hiring for the next 25 right now to have a product that's really well-rounded. And for many companies, that seems like an investment that they don't want to make, right? Hiring 50 people for something that's not core to their business.
Yeah, exactly. And it is early days, right? So they might only have small fleets. Okay, I think that's more or less settled the result on that. Let's move through to the poll question number 3 is, which battery intelligence feature interests you the most? Is it battery performance? Is it battery safety? And naturally, fires is something we talk about quite a bit because they really do capture the headlines. Battery lifetime, because of course that's also important if the battery's going to kind of pay for itself over the life of the asset, or is it none of the above? Safety. The thing about earlier this year, we did with PV Magazine Australia, we did a whole roundtable, and we called it a PV Magazine Insight into battery safety. And there's a huge amount of interest because this lithium-ion technology, all the different chemistries of it or sub-chemistries of it, is a very powerful technology, right? Yeah. And this is a great thing because it means it can do a lot of things, but it does also bring risks with it, I suppose.
Absolutely. And I mean, if you look at how long we've been building and operating coal power plants, for example, compared to lithium-ion batteries, we're in the early, childhood of the technology. And so it's kind of expectable that nothing is perfect from the very beginning. But I believe now is the time that we're moving into giga and terawatt scale to implement the learnings that we've already made to make sure this technology is moving as fast as possible.
Yeah, and safely.
Yeah.
Okay, well, let's go back to your presentation, Kai-Philipp, because we have a couple of questions that pertain to certain slides. So slide 15, 16, and thank you everyone for filling in our polls. That's very, very helpful for us. Slide 16 and 15 and 16. How do you know that the Accure SOC calculation is better than a local BMS calculation without having a calibration?
Yeah, that's a good one. I mean, we do have the unfair advantage of being able to look front and back, whereas the local BMS only sees a quite short amount of data that happened in the last few minutes, and what's happening now. And so we have more computing power, and we can basically calculate going forward and going backward. And we can also basically compare the data for consistency with the operation of the rest of the plant. And so we have a high, we feel quite confident that our estimation is the better one in this regard. Okay.
And then another one, what is the benchmark used to determine the SOC error? What is the error in MV? I think that's millivolts. LFP, lithium-ion batteries, have a very flat SOC to OCV curve.
That's right. So LFP batteries, the OCV, the open circuit voltage curve, is really flat in the middle, which makes it difficult to use. There's basically two ways you can calculate in state of charge. One is based on current, one is based on voltage. And if you have a flat curve, this means there's a very low correlation between the voltage and the state of charge. So that makes it more challenging to do this. I don't know what the error in millivolts is. We can look that up, certainly. I don't have it on the slides now. But again, the ability to calculate in both directions, and also, and that's in this case maybe the more interesting thing, to get the true current out of the measured current, because current measurements, especially DC current measurements, have quite substantial errors on them. And we, with our methods, have found some quite successful ways of cleaning the current, which automatically leads to better SOC estimations as well.
Okay, another SOC question. The average SOC estimation difference we see here is the range of 3%. Is that critical for aging estimation as well as safety over battery lifetime?
I would say 3 to 5% are not critical to aging or safety. The thing that we see with LFP, and that could also be safety critical, is if you are too optimistic on the state of charge that you have, you might run into a deep discharge, because the local SOC estimation tells you there's still 5% energy left. And then you want to tap into those 5% only to find there was nothing left, and you're already below what is, technically specified. Tesla has run into this problem with their China LFP cars a lot. We've seen other companies run into this problem as well. And that's actually really critical, because if you deep discharge a battery below a certain voltage limit, the copper that is collecting the current from the anode can go into solution. And you don't want metal particles floating around in your battery. So a battery at a certain level of deep discharge, especially if it's there for a longer time, might be a complete loss, because once the copper has dissolved, at any time it might spark a fire, it might spark a dendrite. And so a battery that is deep discharged for a longer time needs to be decommissioned forever. And so that might be like the worst case scenario coming from a bad SOC estimation.
Okay, now can we skip forward to it? I think it's slide 19. That was the battery that was leaking some lithium. One question: can state of health be tracked during many years of operation? Oh no, how can state of health be tracked during many years of operation without executing a full test routine?
Yeah, so that's of course one of the main challenges that we solve, and one of our core IP. What we basically do is we look at input and output of the battery at all times and look how it changes over time. One example that I can give you is, for example, we reconstruct only from operation the open circuit voltage curve of a battery and how it changes. And by the way of how the open circuit voltage curve changes over time, there's a few interpretations you can make about it. And these interpretations go down to a level of, how much active lithium, for example, do I have still left in my cell, which then can translate into a state of health. And of course, the battery needs to do something in order to be monitored in that way. But we've been able to basically run this algorithm on a variety of different use cases, stationary, mobility, power tools. And it has worked quite excellent, and just gives us the confidence to work with this.
Okay, in terms of this chart in particular, why is it that you think that the active lithium is rising from month 3 to 6? You can see that little uptick there.
Honestly, that would be a stretch. You can read things into these charts, but there's always, this graph is filtered a lot to make it look nice, to present it to people. But the signal to noise ratio that we have, it can't be perfect. We're working on imperfect data. And so what's really for us is trends. And what we can see from month 7 to month 12 is a constant trend with a steep increase. And that's something, if that happens over many months, weeks, we have the confidence to say, wow, this is something substantial. But if we have a small blimp in the data, that could be anything.
Okay, last couple of questions. You've only got a minute or two. Kai-Philipp, do you have any temperature data on that battery pack?
Certainly.
Yeah. Okay. So and then another question, what's the influence of the location, local climate, in terms of fire risk and aging? Is there an influence?
So battery packs should be quite, I want to say, immune to most typical climates. I mean, it's really a question of system design. I mean, for some power electronics, we know that if the elevation is too high, they get problems with cooling. But for batteries, really, if the system design is good, they should be shielded from whatever is outside. So it doesn't really fall into our scope, I would say.
Okay. Kai-Philipp, I know you have another engagement now. So unfortunately, we have to let you go with many questions left unanswered. Perhaps we'll have to talk about this again on a PV Magazine webinar. Kai-Philipp Kairies is the CEO of Accure Battery Intelligence. Thank you very much for joining us today.
Thank you all.
Fantastic. And thank you for your attendance to this webinar. We had many more questions than we could get to. My apologies for that, but thank you for your interest. As Kai-Philipp did mention, I'll let you go now, Kai, and I'll do the wrap up here so you can join your next appointment. As Kai-Philipp did mention, he did provide an article, I think it was for the November edition of PV Magazine Global, and the January edition is just fresh out. So I do encourage you to take out a subscription. You get a 10% discount with that webinars 10 code. In the January edition, we have the winners of our 2021 PV Magazine Awards, including in the BESS, the Battery Energy Storage Systems category, but there's 8 award winners, all selected by independent juries. So I encourage you to pick up an edition of the magazine. There's some of our most read online articles from just the recent week or two. So you can use that QR code to check those out. And of course, we've got some webinars coming up as always on the 25th of January, just next Tuesday, a webinar understanding and mitigating the dangers posed by hail and wind. Weather effects are an increasingly important part of our industry today. And then on February 10, reducing the environmental impact of PV mounting structures, going from the ground up in our next webinar in February. I have a question coming in. Will the slides be available? They absolutely will be. Check your inbox for a link, not only to the slides, but also to a recording of this presentation. And I encourage you to share that with colleagues and friends who weren't able to attend live. But at this stage, we have hit the top of the hour, so our time is up. Thank you very much for your attendance. Stay in touch with pvmagazine.com and all of our regional sites to learn about the PV industry and, of course, the energy storage industry as well. All the latest news, views, and opinion published on a daily basis, and subscribe to PV Magazine. I'm Jonathan Gifford, the editor-in-chief of PV Magazine Global, and thanks for your attendance today.